We're going to practice utilizing the formula that we derived in the last video, where we're going to calculate the minimum sample size required in order to achieve a certain margin of error. So in this problem, we've got an internet marketing company wants to determine the current percentage of customers who click on ads on their smartphones. A survey from 5 years ago shows that 45% of smartphone users click on ads. So this is giving me a prior estimate. In these types of problems, we usually hope that we're going to end up with a prior estimate, meaning p hat in this case is going to be 0.45. Now, if 1 is not given, then we are going to assume p hat will be 0.5 if 1 is not given. And that's just what that does is it maximizes the sample size. It gives us the safest guess. But in this case, we have a prior estimate. We can use 0.45. Getting back to our problem, how many customers? So first of all, how many customers means what is n? That's what I'm going to try and solve for here. I know that I'm using this formula. How many customers should the company survey in order to be 90% confident? So pause for a second. My confidence level is 90%. That's really important because that's going to tell me my Z star. I have to know my confidence level if I'm going to know my Z star. So the Z star corresponding to a 90% confidence level is 1.64. Remember, you can look this up using your critical Z-scores table that should be included with the formula sheet for this particular chapter. So we've got our 90% confidence that the estimated proportion is within 5 percentage points of the true population proportion. So we want to be within 5 percentage points. What that means, if we were to draw this out, what that means is, remember when we build a confidence interval, we say here's p hat, and then we add our margin of error, so p hat plus my margin of error, and we subtract my margin of error. I want that margin of error to be 5 percentage points, or 0.05. So it's saying I want on either side to be 5%. When we give the margin of error, we always want to give it in its decimal form. So my margin of error will be 0.05 on either side. So my m will be 0.05. And if we can grab all that information from our problem, then for the most part, these questions will be fairly straightforward. We're just going to take our p hat, our Z star, and our m, and we're going to plug those into our sample size formula over here on the left. So n is equal to Z star, that is 1.64 squared, times p hat is 0.45, times 1 minus p hat, 1 minus 0.45, divided by my margin of error, 0.05 squared. So grabbing my calculator, let's be very careful. 1.64 squared times 0.45 times 1 minus 0.45, and then we're going to divide by 0.05 squared. I ended up with 266.2704. We'll say just 27. Now remember, n represents a sample size. N cannot be a decimal because n is referring to, in this case, the number of people that I would like to go out and survey. So what this means for me is that n can't be a decimal, and I know that if I round n like normal, n will go down. If I was going to round like normal, I would say it's 266, and fine, that's the end of my problem. But if I decrease my decrease my sample size, that will increase my margin of error, which means my margin of error would actually be a little bit above 5%. I don't want that. That's a condition, a necessary condition. So what that means is that for these types of problems, n always has to go up. So n is not allowed to go down, n is only allowed to go up. So n should be 267 for this particular problem. This is the only time that we'll use that special rounding rule, so just be careful that you don't accidentally carry it over to any of our other problems. Solving for sample size for n is the only time we will use this special rounding rule. Any other time you can round just like normal. This is the only instance that we're going to use it.